Okay, example 4 for graphing rational functions. First thing you want to do is simplify. So I'm going to factor the top and the bottom to see if anything cancels. Okay, when I factor that, I'm going to get 3x minus 4 times x minus 2 and 2x plus 3 times x minus 2. So as you can see, I have a factor that cancels, and after I cancel that, I'm going to get 3x minus 4 over 2x plus 3 as my simplified version. So let's list out all of our key features. Okay, so because we have a factor that cancels, I look to see what value of x makes that factor 0, and in this case, if I look, it's going to be 2. To find the corresponding y value of the whole, we have to plug it in to the simplified version. So if I take 2 and plug it in here, I'm going to have 3 times 2 minus 4 over 2 times 2 plus 3. When I do that, I'm going to get 2/7. For my x-intercept, I want to look after simplification what makes the top 0. And again, if you can't do it in your head, do some scratch work off to the side and set that top equal to 0 so you can see what that value of x would be. So when you do that, you get 4/3. If I write it as an ordered pair, it would be 4/3, 0. The y-intercept is the value of y when x is 0, so I would plug in 0 everywhere I see x, and I would get -4/3. If I write it as an ordered pair, it would be 0, -4/3. For the horizontal asymptote, we want to look at our rules, and in this case, the degree of the top is the same as the degree of the bottom. They both have a degree of 2. So when the degrees are the same, we take the leading coefficient of the top and divide it by the leading coefficient of the bottom. If I look, here's my leading coefficient of the top, here's my leading coefficient of the bottom. So my horizontal asymptote is going to be 3/2. My vertical asymptote is after simplification what makes the denominator 0. So again, if you can't do that in your head, write some scratch work out and solve 2x plus 3 is equal to 0. When you get that, you're going to get x is equal to -3/2. Now we're going to put this all together. Using a scale of 1, I have a whole at 2 2/7. So over 2, up here somewhere less than 1. Then I have an x-intercept at 4/3, and that's 1 1/3. So it's going to be about right here. I have a y-intercept at -4/3, which is -1 1/3, so about right here. I have a horizontal asymptote at 3/2, which is 1 1/2. And I have a vertical asymptote at -3/2, which is -1 1/2. Then we put this on the calculator to check to see where our arrows are going to go. We're going to put it in as y equals, and then in parentheses, 3x squared minus 10x plus 8 divided by, then parentheses again, 2x squared minus x minus 6. When you do that, you're going to see that your graph comes down on the right. So to the right of your vertical asymptote, it's going to go down, and then it's going to flatten out here. And then on the left side of your vertical asymptote, it's going to go up and flatten out here. Now, something to keep in mind when you're looking at your graphing calculator, the graphing calculator doesn't have the capability of actually showing you the hole on the graph. So when you look at your graphing calculator, if you don't see a hole there, don't panic. What you can do is you can actually just plug it into your table, or you can use the calculate feature on your graph, and you can actually plug in 2, and then if it comes up blank or undefined, you'll know that you've got it right, because even though it doesn't show it on the picture, because it's incapable of showing that graphic on there, you'll be able to see that the calculator, when it does it, plugs it in on your table or wherever you plug it in at, it's going to show you that there's nothing there. It's undefined. So keep that in mind when you're looking at a graph and you've got a hole, that your calculator is not capable of showing you that on the actual picture.